Hello guys, my name is Lazaro and today we're going to be doing a LeetCode problem. This problem is called Search Suggestions System. Given an array of strings, products, and a string search word, we want to design a system that suggests at most 3 product names from products after each character of search word is typed. Suggested products should have common prefix with the search word. If there are more than 3 products with a common prefix, return the 3 lexicographically minimum products. Return list of lists of the suggested products after each character of search word is typed. Cool. So they told us what our input is going to be right here, what our output is going to be over here, and then finally everything in between is defining the problem or how we should go, uh, how we should tackle this problem. So this is pretty common, use suggestions for searching. If you go to Google and you start typing something, uh, those suggested searches is pretty much operating the same way as we're doing it here, as we're going to do here. So let's look at the first example. We have products, which is equal to mobile, mouse, money pot, monitor, and mouse pad. Then the search word is mouse. Let's go back to the description and then let's remember that we should be returning at most 3 product names from products after each character of search word is typed. So we first type the character M, and now let's look at our products array and find 3 product names that have M as a prefix. Because remember, the suggested products should have common prefix with the search word. So currently the search word is just M. Therefore, if we go through this products array, we should be returning mobile, money pot, and monitor. The reason for that is because although we can recommend all of these, we must only recommend at most 3. And these ordering should be lexicographic, aka just ordering them by their letters. So that's where mobile, money pot, and monitor comes from. The next character we type is O. So currently a search word just MO. And if we type MO, we can still suggest all of these, but again, we only want to do uh, the first 3 in a lexicographic order. Therefore, the answer is still mobile, money pot, and monitor. Our next character is U. So now our search word is MOU. And now we can only recommend mouse and mouse pad. Therefore, that's all we're going to output. Then the next one is S, so our search word is now MOUS, and we can still only recommend mouse and mouse pad. Therefore, that should be our output once we type the letter S. So, and then it's the same thing for once we get to E, our search word is mouse, and we can recommend mouse, and we can also recommend mouse pad or suggest mouse pad. So our output is we an array of arrays. The length of this output arrays will be the same length as our search word. And then for every array within our main array, it represents the what the system is suggesting for that prefix. So this first array is what the system will recommend for just M. Second array is what the system will recommend for MO. Third array is what the system would recommend for MOU. Then fourth, MOUS. Then fifth, MOUSE. And then here they have a couple other examples, but it's pretty much the same thing. For example 4, the search word starts off with a T. Now in our products, there is no product that the prefix is T. Therefore, we cannot really recommend anything. And that's why all of these are empty. So how can we solve this problem? Well, this problem takes advantage of a pretty useful data structure called a trie or a prefix tree. If you guys haven't heard of this data structure, then I highly recommend you watch a couple of videos on it because I'm not gonna go really in depth into it in this video. This video is more of me assuming you know the data structure or have some knowledge of it, and we're going to be solving this problem with that data structure. It's not really a lecture on the data structure itself. Alright, so I went ahead and just drew out the prefix tree or the trie tree for this products array right here. So this is the one in the first example. Now, for this tree, there's something else that we want to include for the nodes. And that is, we want to know which node represents one full word in our products array. The reason for this is because if we were to look at this mouse pad, or this path right here starting at M, I really cannot draw a straight line, starting on M and going all the way to D right here, we need to realize that there's two words in this path and not just one. So what we have to do is add an attribute to each and every single node. At the node that represents an end of a word, let's just add a check mark to them. And we can represent this in code by just saying that, for example, node E dot word, you set that equal to true. So let's give each node an attribute called word. And since E is the last one for the node mobile, we want to set this to true, and I'll represent that by a check mark right next to the node. Now we also want to do this for the E in mousepad and the D in mousepad. And then finally the T and the R for both moneypot and monitor. And I'll explain why this will be useful for solving this problem. So let's also remember that our search word was mouse. And let's remember that we're typing this search word one by one. Therefore, in the beginning, we just type out M. And now with this M, with this prefix, we want to get to this node, or we want to traverse this tree to have the same prefix as we currently have right here. Since it's just M, we start at our root node and ask if we have this next character M in as one of our children. In this case we do. So we go to M. And now we're done. We have successfully seen this prefix M, and there's nothing else. So what's remaining now is that we need to, starting at this prefix, let's traverse it all and see how many words we see. In this case, if we were to traverse it, we will go from M to O, then B, I, L, and E. And then one word we would see is mobile. Then another word, we will go from M to O, then U, S, E. So that right there, we already see mouse. Might run out of colors here. And then from E, we continue with P, A, and D. So another word is mouse pad. Then from O, we go to N, E, Y, P, O, and T. And we know this is another word because it has that check mark, so we add that. We add money pot. And then finally, I guess I'll do this one in blue. We go from O to N, I, T, O, R. And R has the check mark, so we know this is another word. So we add monitor. And this is all the words that we can see that has a prefix of just M. Now, of course, we only have to return 3, and we have to select these 3 based on their lexicographic order. So in this case, it's just going to be mobile, money pot, and monitor. And let me make sure that's right. Yeah, perfect. The reason for that is because they all have an M and O, but B comes first in the alphabetical order, and then these N come first, then the U's. Therefore, our three is going to be mobile, money pot, and monitor. So we can add this information to our array that we're building out. Let's say we have an array here. For the first prefix of just M, the words we can return is mobile, money pot, and monitor. Perfect, so that worked out. Oh, actually, you know what? Let's not keep that array because I am going to have to go all the way back. I actually don't think I could go all the way back. No, that's as far as it can go. This is unfortunate. Alright, so I just went ahead and redrew it, and also added back the array. Cool. So now let's get to the next character we'll be adding. If we previously searched for M, then the next character we would search for, or the next character we would insert, is O. And now this is our new prefix. So we want to do the exact same thing to this tree. Starting at the root, can we reach M? Well, we could, therefore let's go to it. And then after M, can we reach O? Well, we could, so now let's go to O. Now we've successfully seen this whole prefix that we've searched for so far. Now I did forget to add back the green check marks to our tree to represent which nodes are a word. So let me just add it quickly. Perfect. So now with this prefix completed, let's DFS through the remaining tree. And for every word we see, let's add the three, at most three. And let's take into account their ordering. So if we're at O, I think you guys can agree that we'll be seeing the exact same words as last time. From O, we can reach everything else, which is all of this, the two words in here, and then, whoops, this right here, and then monitor. So not much is going to change if we were to start at O, or if we had this prefix MO. So I'm just going to be saving some time, and let's agree that since we're seeing all the same words and we could do the exact same steps as last time, our answer would still be mobile, money pot, and monitor. So let me go ahead and draw that out. Perfect, so there we go. Now we want to go to the next word. And in this case, the next character we're going to type is U. So now our prefix is MOU. So now let's try to obtain this prefix. So starting at the root, can we go to M? We could. Therefore, let's go to it. Can we go to O? We could. It's one of the children of M. And then from O, can we go to U? We could, because U is a children of O. Now in this case, we have completed this whole prefix. So now starting at U, or for starting at this prefix, how many words contain this prefix? And we can figure that out just by running DFS from this U node, or the last node in our prefix. If we go to do that, then we're going to be seeing two words. From O, we're going to go to S, and then from S, we're going to go to E. And we notice that E marks one whole word. Therefore, we're going to add that to our array. So I'm just going to write out here, mouse. Let's not add it to our array to this main array out here just yet, because we might see more than 3. So let's carry on. Then from E we go to P, from P we go to A, and then from A we go to D. And D is uh, the end of a word, therefore we can add mousepad to this array we have. Now we have finished. There's no other children that D can lead to. So the only two words that we want to add is mouse and mousepad. Therefore, let's take these two words and add it to our main array. So now we have mouse and then mousepad. Perfect. Now we want to continue doing the exact same thing. Now we want to add this new character which is S, and that changes our prefix. But notice how we're still going to start in here. Therefore, the only two words we're going to see is mouse and mousepad. So it's be the exact same answer as before, and I'm not going to write it out. Now, as soon as we add the E, our prefix is now mouse, and we finish on a node that is a word, and we still want to include that. So although we finished on the E, since E is a word, let's go ahead and include it. That makes our answer still mouse and mousepad. Meaning at the end, our answer array will look like the following. And now we have our answer array fully built out. Now, one of the main things to answer this problem is just to build out our current search word one by one. And for whatever prefix we're on, let's traverse the tree, get to that prefix, and then wherever we finish, let's run DFS from there. So let's get to the code and let's implement this. We first want to build out this Trie, which means we have to build out a node class. And this node class can have a value where the value represents the character. Now, by default, I'm just going to set this value equal to a empty string. Now let's set value equal to value. Let's also create this next attribute, which I'm going to be setting it equal to a dictionary or a hash map. And then finally, we want to tell if this current node is a word or if we are done or not. And we can do this with an attribute called done. If done is true, then we know that this current node represents one whole word in our products array. Now this is all we really need for this node class. The next class we want to do is the actual trie itself. For this trie, once we initiate it or instantiate it, the root is just going to be equal to node. And since I didn't pass any arguments, it's going to set value equal to empty. Then we also want to create another attribute, which is called res for result. And this result would hold the temporary words we've seen for the DFS. Now we want to be able to insert words to our trie tree. So let's create an insert method where we are trying to insert some sort of word, which in this case I just called word. So let's set current equal to self.root. And then for every character in the word, let's see if this character is already in our tree. So let's set node equal to cur.next.get this character. And if this character is not in our tree, let's default by creating a node for this character. And then let's set the next for this character equal to this new node we just either created or retrieved. And then let's update our current to be equal to that node because we want to fully build out this word. And then finally, let's set cur.done equal to true because we have successfully built out the whole word. Therefore, this last node does represent one word. So what exactly is this insert method doing? Well, let's say I currently have built out the word mouse pad. And I want to insert mobile. Mobile starts with an M, so instead of creating another node with M, let's go to the current node we already have in our tree. This will be much more space efficient. And then mobile, the next character is an O. So let's, instead of creating another O, let's first check if we already have an O as a child or an O as the next node. In this case, we do. So let's go to that. Then the next character is a B. Do we currently have a B? In this case, we are forgetting about this tree right here because we are assuming we only have built out mouse and mouse pad. Since we don't have a B, let's go ahead and create the B. Then let's continue with the I, and then the L, and then the E. And at the last node, we want to set that attribute equal to true to represent that this is one whole word. So that's the reason behind either getting this character or creating it or defaulting to creating a node for this character if it's not in our tree already. Now the next method we want to create is find, where we're trying to find this word. Let's set cur equal to self.root, and then for every character in the word, let's try to retrieve this character. So similar how we did in insert, let's set node equal to cur.next.get this character, and let's default to false if it's not in our tree. Now, if this is false, then we know that this prefix is not in our tree. Therefore, we want to just return an empty array because there's no words that have this prefix. If this is not the case, then let's update cur and let's set cur equal to node. Now this for loop is going to fully build out the prefix of whatever word is. Now we want to set self.res equal to an empty array, and we want to start our DFS. So let's create a DFS function, and we have to start at this node, whatever node we're going to pass it, and we're trying to find, or so far we have built up this word. Now the first thing that we want to check is if node.done is true, then we know we have seen one full word. Therefore, let's append this word that we have built out. Else, for every character and the next node that that character represents, in node.next.items, let's call DFS. With this next node, and the current node that we have built out is the word that we have previously plus this character. So initially we want to call this DFS function with cur and with word. So starting at this node, which would be the node that represents the last letter in word, and with a prefix of word. Now let's sort this result array because we want to only get the lexicographic, because we want to take into account their lexicographic ordering. Now if the length of self.res is greater than 3, let's just return the first 3. Else we can just return the whole array. So this is all that it takes for our trie tree. Now all that we really need is down here in this solution class. We first want to initialize our trie class. Now for every product in products, Let's insert it to our trie tree. Then finally, let's initialize answer to an empty array, and then the word that we have typed so far is initially empty. Now for every character in search word, let's add that character to our word, where this word represents everything we have typed so far, aka a prefix. It will represent either a prefix or the whole word. And then for our answer, let's append whatever root.find for this prefix returns, all the words that have this prefix in our trie tree. And then finally, we can use return answer. So let's run the code for this. Let's see if I made any mistakes anywhere. Okay, I didn't. Let's try some more test cases. All right, it's accepted, and now let's submit. And it works perfect. So this was a probably really long video, and it's just a hard concept or something that takes a while to fully explain how trie trees work or prefix trees work. But hopefully you guys can follow along. If not, then look at this code right here. The most important part is class node and class trie. And let's scroll back to where we were showing with the drawings how we could answer or solve this problem, and try to connect what we talked about to what is shown in this code. But other than that, I hope you guys enjoyed. If you did, please leave a like and consider subscribing. And thank you guys for watching.